All right, you guys, now we've got section 4.2, translations of sine and cosine functions. So we still have the same exact shapes of the graphs. We have the S of the sine graph, and we have the C pretty much for the cosine graph. And you can see that this graph is a little bit more humpy, if you will. It has an amplitude of 3, meaning it goes between 0 and 3, and 0 and negative 3. And so this one, what you can see is we have moved it either to the left or the right. I'm going to talk about that in a second. But if you remember from Algebra 2, when you have something that looks like this, maybe you've seen something in Algebra 2, obviously without the word sine here, but maybe you had a 2 exponent up here, and that would represent a parabola. And when you have a negative number inside the parentheses, that actually represents a right shift. I'm not sure if you remember that from Algebra 2 or not, but this shift over here with a positive number inside the parentheses actually means shift to the left. So those are Algebra 2 topics that you need to be able to recall in this type of a setting here with sine and cosine. But we have our regular sine graph here, the normal one that we graphed very first thing on the very first page of section 4.1. And then if you actually have a minus pi over 3 here, that shifts it to the right pi over 3 units. And yes, that changes all of our x-axis numbers, and I'll talk to you about how that is going to be affected in a second. But just notice that it's just the regular sine graph with an amplitude of 1, since there's only one, or there isn't a number with the sine, it's just an understood 1 leading coefficient, but it's moved to the right pi over 3, and that took all of our dots and moved them to the right pi over 3 units. Same thing for this cosine graph here. We have our regular cosine graph, but it has an amplitude of 3, and that's why it's a little bit more humpy. So it started at 3 instead of 1, and it goes down to negative 3 instead of negative 1. But you can see that it's plus pi over 4 here in the parentheses, and that means to the left pi over 4 units. So instead of starting at 0, 3, they started at negative pi over 4, 3. So it's literally like dragging all 5 of those points that we graph to the left pi over 4 units, and it's just a shift. Okay, the other way that we can shift these graphs is a vertical shift. You can drag this sine curve up and down sometimes too, or this cosine curve can be moved up or down. That is a vertical translation. And so what that looks like is usually they write it very first thing in the equation, but here's what the equation of this graph is. It has a hump of negative 2, which means it actually starts down. The period has changed because of this 3 in front of the x, and we'll talk about that also. We'll review that. That's why there are so many humps between 0 and 2 pi. That's because of the 3 right here. But this 3 right here is a positive 3 that is being added to the function. What that does is it takes it from the normal centered along the x-axis here, and it brings it up 3 units. So it has been shifted up. So those are the things that we're going to be talking about today. Okay, so flip the page, and I have a couple things for you to copy down. So it sounds like, or it looks like a lot of stuff to write here, but I'm just going to go right into this very first example, and I'm going to refer up to this so that it makes sense, like why I wrote what I did. So very first thing, I can see that this is a sine graph, obviously. Tells me to graph one period, and there is not a number here with the x, so I know that my last tick mark, or my period, is going to be 2 pi. I can see that it has been moved to the right pi over 3 units. I'm going to make a little note about that. Right pi over 3. And again, that's because it's minus pi over 3 in the parentheses. Just like for Algebra 2, that represents a shift to the right. Okay, so that's actually the first thing that I'm going to do, is I am going to put my very first tick mark to the right pi over 3 units. Okay, so that is the very first thing that I wrote up here in the top of the notes. Start by putting a tick mark at the left or right shift. This is right pi over 3. That means I'm going to start my graph here at pi over 3 instead of starting it at 0, which is where we've been starting all of our other graphs. Okay, thing number 2 says to figure out the period. And when there is not a number here, a coefficient in front of the x, that means it's just the normal period. That does not mean that my last tick mark is going to be 2 pi because everything shifted to the right pi over 3. So what I have to do, my whole period is 2 pi, and what I'm going to do is divide everything there by 4 because I need 4 other tick marks. And so that means each tick equals 2 pi divided by 4 is pi over 2. So what I'm going to do is add pi over 2 each tick mark. So the second one is here, third one is here, fourth one is here, fifth one is here. Okay, so here's where, again, fraction work. We got to come in thinking fractions here. I'm going to make a common denominator of 6. That's going to be 2 pi over 6 plus 3 pi over 6, which gives me 5 pi over 6. I'm not going to continue writing out all of these fractions every time because you guys should be able to do this part. I'm going to add 3 pi over 6 again, which gives me 8 pi over 6. Yes, that reduces. I'll do it in a second. Then I have 11 pi over 6 by adding 3 pi over 6 every single time. And I'm going to add 3 pi over 6 one more time, which gives me 14 pi over 6. Yes, a couple of these reduce, so I'm going to do that. This would be 4 pi over 3. This would be 7 pi over 3. I'm going to show you a trick here just to make sure that you have labeled your x values appropriately. Like here's a little check that you can do. Remember how the period should be 2 pi because we don't have a number up here. So what that means is you should take your last tick mark and subtract your first tick mark, and the distance in between them should be exactly 2 pi. If it's not, you know you made a mistake with your fraction somewhere. So what I'm going to do is take my last tick mark. I'm going to leave it in common denominator form instead of reduced form just so that it's easier to subtract. 4 pi over 6, the pi over 3 was the same as 2 pi over 6. That gives me 12 pi over 6, which is 2 pi. And that was my period, so I know I labeled my x values appropriately. So that's just a little trick for you in case you are a little bit nervous about all this fraction work down here. I'm going to pause for 1 second, and I'm going to re-explain kind of what I just did because in case you missed something. This negative pi over 3 within the parentheses means shift to the right pi over 3. That's my very first tick mark. My last tick mark is not going to be 2 pi because everything was shifted to the right. However, because there is not a number here with the x, that means that my period is 2 pi, which means the distance between my first and last tick mark is 2 pi. In order to figure out what each tick mark was, I took my period and divided by 4, and that gives me pi over 2. So I had to add pi over 2 each time to label all of these. And just to check to make sure that I did that correctly, I took my last tick mark and subtracted my first tick mark and made sure that it equaled 2 pi, which was what the period is supposed to be to begin with. And so now what step 3 up here says to do is use amplitude and or vertical shift. So our amplitude is just 1 because the coefficient in front of sine is 1. And there is no vertical shift because I don't have a plus anything or minus anything outside of the parentheses, so I'm not moving my graph up or down at all. So therefore I can just use the pattern of the sine function. So you should have an idea by now of what the sine function looks like. It starts at 0, but don't put your first point here. Put it on the first tick mark because remember we shifted everything to the right. So that very first tick mark is there for a reason. Started here and then it goes up to 1, and since the amplitude is just 1, those numbers are not different. But my second point is here. Now I'm just following the pattern. Down here and back. And I'm going to connect my dots. You should always have 5 points for these graphs. And that is the graph of the very first question. Okay, let's try another one. Let's do this cosine one. Again, I'm just going to follow those steps up at the top. And the very first thing is to put your very first tick mark on whatever the shift is. And in this case, I am shifting to the left. Be careful because it's plus pi over 4. That means left pi over 4 units. So I'm going to put my very first tick mark over here to the left at negative pi over 4. That's the very first tick mark, and for cosine, my very first dot is going to go somewhere along that negative pi over 4. Now I need to label all of my other points. So step 2 up there says to figure out the period. And again, I do not have a coefficient here with the x. There's no b term here, it's just 1. So my period again is 2 pi. But remember, I have a left shift here, so that means my last tick mark is not going to be 2 pi. That's just the distance between my first tick mark and my last one. And so in order to figure out what each tick mark is, I have 4 more tick marks, so I need to divide by 4, and that means that pi over 2, is each tick mark. So what I need to do is add pi over 2 to this. And I'm going to continue adding pi over 2 each time. 2, 3, 4, 5. Those are my 5 tick marks. I'm going to add pi over 2 to pi over 4. In order to get a common denominator, it's the same thing as 2 pi over 4. So here comes the fraction work. Negative pi over 4 plus 2 pi over 4 is 1 pi over 4. Add 2 pi over 4 again, you get 3 pi over 4. Add 2 pi over 4 again, you get 5 pi over 4. Do it one more time and you get 7 pi over 4. None of those reduce, so that made it a little bit easier that I don't have another step that I need to do. I'm going to do my period check over here just to make sure I haven't screwed up my fractions. I should be able to take this number and subtract this number and it should equal the period, which is 2 pi. So in this case, I'm doing 7 pi over 4 minus negative pi over 4. Be careful, it's minus a negative, which is 8 pi over 4, which is 2 pi, which is what I'm supposed to have for my period. Okay? So that's, again, just a smart little check to be able to make sure that you've done your fractions and stuff correctly. Okay, so now I have my 5 x-axis labels done. And so now I have to think about cosine. Where does my first dot go for cosine? Cosine of 0 is 1, and so that's why cosine starts at 1, but in this case it doesn't start at 1, it starts at 3, because I have an amplitude here. That makes it more humpy, remember? And it's a positive 3, so I'm starting up at positive 3, not down at negative 3. So I'm going to label those here. This is 3, this is negative 3. And remember, don't put your first point on 0 because we shifted. Your first point goes labeled here at negative pi over 4. So at negative pi over 4 comma 3 is where my very first point goes. I'm going to put it right here on top of the 3. It's getting a little bit messy. Then I go down to 0. Then I go to negative 3. Then back up to 0. And then positive 3 again. So remember, the cosine curve looks like so. You have to be careful to label your x-axes appropriately and then take into effect that amplitude, or if there's a vertical shift, which again, we don't have a vertical shift over here. So I'm going to quickly go through this last example. I need to point out something really important for an example. It looks like this. So just to breeze through what this is going to look like so you have an idea in your head, this is a cosine graph. There's a -2 amplitude, so that means it starts out going down. That's where the negative comes into play. It's been reflected over the x-axis, and it's a little bit more humpy than usual, so my y-axis labels are going to be 2 instead of 1. And I have a shift here, and something's messing up the period. So what I need to do first is make a huge note about this, you guys, is that this 3 needs to be factored out. Must be factored out. So here we have to think about some algebra 2 stuff. The equation I'm going to graph is y equals -2 cosine. Take out the 3. That makes it x plus, how do you take a 3 out of pi? So you guys know how to distribute, right? That's multiplying. So to take something out is dividing. So I'm just going to leave it as pi over 3. And you can check your work by redistributing that back in. 3 times x is 3x, 3 times pi over 3 is pi. So to take a value out, you're dividing. When you distribute, you're multiplying. Okay, so that needs to be taken out. This is my b value, and that's how I'm going to use the b to figure out what the period is. The amplitude is the -2, that stayed, but my shift is actually to the left, pi over 3. Okay, so remember, that's the very first thing I'm going to do. I'm actually going to extend this over here. You'll see why in a second, but my very first tick mark is going to be -pi over 3. Then remember, second thing I'm going to do is figure out what the period is. I'm going to pause the video and write it out and then label all my x-axis values as well. I dare you to pause the video and try to label the x-axis on your own. Okay, so how did you do? This question's a little bit different because, again, I just went through the period math that I kind of do every single time. Your period is always 2 pi over b. The b is 3. So 2 pi over 3 is the entire period. That means when I subtract my last tick mark minus my first tick mark, it should equal 2 pi over 3. I'll talk about that in a second. But remember, take the period and divide it by 4, and that gives you what each tick mark is. There's some more fraction work that you need to be okay with here. 2 pi over 3 over 4 is the same thing as multiplying by 1/4, which gives you 2 pi over 12, which reduces to pi over 6. Again, more fractions. Negative pi over 3 plus pi over 6. Get a common denominator. It gives you negative pi over 6. That's why I have 2 tick marks over here. And then when you add pi over 6 again, you get 0. Add pi over 6, you get pi over 6. Add pi over 6 one more time, 2 pi over 6, which reduces. So here are all my x-axis labels. Okay, only other thing I need to take into account here is the -2. And so that means that I have to have tick marks here of 1 and 2. And this is -2 down here. And then just remember that cosine, my very first tick mark, is going to be somewhere along here at negative pi over 3. But cosine starts at 1 usually because cosine of 0 is 1. But multiply that number by -2, which means it starts down. So my very first tick mark is down here, and then follow the pattern. So it looks like this. Okay, so that is all for today, you guys. I know it's kind of a lot and you just have to keep practicing, but we will continue to go over questions in class and practice more and more and more and make sure that you're okay with all the rules and regulations of these. Thank you for watching. I'll see you tomorrow and we'll finish the other 2 problems for this section, okay? Have a good night.